In today's class, we will learn about the monohybrid cross. Monohybrid cross is a cross in which only one character is taken at a time for analysis. This was a classical experiment of Mendel. So, Mendel took only one character, that is one pair of contrasting character to perform this experiment. So, Mendel took tall, capital T and short, that is dwarf. This is and this is dwarf. When he crossed these two, what he found? Let's see the gametes first. These are gametes. And this is small t. So when he crossed these two, if we cross it, so this also we are getting capital T and small t. So this was F1 generation. Now all of you see here, this is phenotypically tall. All the four progenies are phenotypically tall. So this is phenotypic tall. Means this is hybrid which shows tallness. Tallness is the character in all the four progenies. You see, all the progenies are tall. This is also tall. So all the progenies in the F1 generation was tall. Mendel was surprised. There was no dwarf character seen. Pure dwarf was not seen. Mendel took two pure line characters. You see, the pure homozygous characters he took, tallness and dwarfness. Then Mendel did selfing of the F1 generation. Selfing of F1. So he took, we can take two characters and find out the gametes here. Capital T and small t. Here also capital T and small t. These are the gametes of F2 generation. Now we can cross over. We have to do crossing over of these gametes of F2 generation. So selfing of the gametes, selfing was done in F2 generation. And the gametes we got is capital T and small t, capital T and small t. So let's do the crossing over of these gametes. We are getting capital T and capital T. Capital T, small t. Small t and small t. So this is what the progenies after selfing in F2 generation, the progeny Mendel got was this. That means one pure tall, this is pure tall, and these two are hybrid tall. These are also tall, but these are hybrid tall, and this is pure dwarf. So this is pure dwarf or pure recessive character was seen. So the ratio what Mendel got is 1 is to 2 is to 1. That is 1 is genotypically tall, 2 are phenotypically tall, and 1 is genotypically, that is pure line dwarf. So this was genotypic ratio. 1 is to 2 is to 1. That is 1 is pure tall, 2 are hybrid tall, and 1 is pure dwarf. Now if we find out the phenotypic ratio, what we get is 1, 2, 3. All these are tall. This is pure tall and 2 are hybrid talls. So we get a ratio of 3 tall and 1 pure dwarf. So phenotypically we get a ratio of 3:1. So we see the phenotypic ratio 3:1. That means 3 progenies are tall and 1 progeny is dwarf. That is, 1 recessive character is seen, which was not seen in F1 generation. In F1 generation, all the progenies were tall, but in F2 generation, the recessive character reappeared, which was not found in F1 generation. With this experiment, Mendel concluded that each genetic factor is governed by a discrete unit, which Mendel called as factor, and today we call them as alleles, and alleles are found in pairs. In a pair of allele, that is, if the pair are in have contrasting character, then one of the pair always dominates the other in a heterozygous condition. You see, capital T and small t. Dwarfness here is a recessive character which has been hidden, or with tallness. The tallness character dominates the dwarfness character, and it is seen, tallness is seen in a heterozygous condition. So the character which dominates, or the character which is seen, physically seen, is known as a dominant factor, and the character which is hidden, which is not seen, or which is recessive, is known as recessive factor. This experiment led to the formulation of Mendel's first principle, that is the law of dominance. So first principle is the law of dominance. The law or the principle of dominance, actually this should be the principle of dominance, which is Mendel's first law. This is Mendel's first law. Now it states that when a cross is made between a pair of contrasting character in F1 generation, the character which dominates the other character is known as dominant factor, and the character which is hidden or recessive stays hidden in the F1 generation but reappears in F2 generation. In F2 generation, the reappearance of the recessive character, Mendel thought that this character does not die. It remains hidden. Which appears in the next generation, and there is also no intermingling of the character. There was no contamination or blending of the character. the recessive character remained in a pure form, and this led to the formulation of the second principle, that is the principle of segregation. Now let us see the binomial expression of the monohybrid cross. The F2 dihybrid ratio, that is the genotypic ratio, is 1:2:1, or we can say 1/4:2/4:1/4 for the characters or the alleles that are capital T is to small T small t is to small t and small t. Now this can be condensed and expressed by the binomial expression of ax plus by taken whole square. So we get half t capital T plus half small t whole square. Now if we express it, then we will get half t capital T plus half small t into half capital T into half small t. So we can conclude that 1/4 capital T plus 1/2 capital T small t plus 1/4 small t and small t. So this was the binomial expression of the monohybrid cross, the experiment which was performed by Mendel. So in this class, we have learned about the monohybrid cross, the experiment which was considered as a classical experiment of Mendel, and this led to the formulation of Mendel's first law, that is principle of dominance.